Hello and welcome everyone to the webinar of Artix. Today's topic is Everything as Code. My name is Pascal Fries. I am a IT consultant at Artix Garching. And I would like to show you some concepts that I love about configuration as code and infrastructure as code, and how to connect both of these concepts. So first of all, I would like to start with uh, yeah, telling you a little bit about myself. As I said, my name is Pascal Fries. I am IT consultant at Artix. My special points of interest are cloud native CI/CD or cloud native, the concept of cloud native applications in general. And with that, of course, the big topic of Kubernetes and containers. And with that, the concepts of infrastructure as code, because infrastructure as code is usually what you do when you want to lift things into the cloud and want to have a repeatable process to be sure that everything in the cloud is doing exactly what it should do. Um, the tools that I use are, I put them on this slide as well. The tools that I use are Ansible, Kubernetes, and Terraform. And alongside that, of course, the usual toolkit, so CI/CD with, say, GitLab or, say, Docker for building containers or Canico and other alternatives. So I already told you that I'm working at Artix. The special thing that makes Artix great for me is that we do a lot of stuff and a lot of stuff with open source. So we are the Linux and open source company in Garching, near Munich. And our big topic is open source automation. So we try to automate processes that have to do with IT in the cloud or on premises. And for that, we use technologies such as Kubernetes, containers in general, Docker, Puppet, Ansible, Terraform. And we also have our own software, which is the Ocarina. And Ocarina is like some uh, central tool that you could use to start automation of any kind via plugins. The big thing about Alex is that we have several different ways that we support our customers. Uh, First of all, we do IT consulting. Second of all, as I already said, we do have the Ocarina, which is our own software. So we provide this software to customers. We provide support for that software. And also, and that's something that's very dear to my heart, is we provide trainings. Um, Trainings in the sense that we teach people how to use these tools, how to use tools in the cloud or on premises. And when we do these trainings, one thing that we always strive to do is automate the process of preparing these trainings, because during our training sessions, um, the participants of any training, they get a piece of infrastructure that they can work on. And this piece of infrastructure, this needs to be provisioned, it needs to be prepared, it needs to be configured. And all of these steps are something that you can very well automate. And of course, as we are a company that's specifically specifically dedicated to automating everything, this is something that's very important. And so we strive to use the DevOps principle to describe our training infrastructure. That means that our training infrastructure is formulated in some sort of code, and the entire release, update, and so on process of that, testing, planning new changes, uh, building new components, all of that is done in version control. All of that is done using pipelines. And for that, we need to choose the correct tools. So the question is, how do we actually prepare our environments in such a way that we can deploy an environment that suits a training for Terraform, or that suits a training for Docker, that suits a training for Puppet, All of these different tools require different infrastructure to work on, because for Terraform, you just need some host where to install Terraform, and then from there on, you can do things in the cloud. On the other hand, if you want to do something with, say, Ocarina or Puppet, you will need several hosts that need to be connected with one another. And we want to have and we need to have a framework that enables us to provision such infrastructure and to prepare it for a training. And so we came up with different concepts, and I would like to present several of these concepts to you. Specifically, one of those concepts that I've been working on, which combines Terraform with Ansible, and I'm very I'm actually very proud of this concept because it works so well, and I like it very much. Okay, so chapter 1. Let's start with what we initially had. And what we initially had was we did everything with Ansible. We had a Ansible monoculture. The general idea was, well, we have Ansible, and with Ansible you can do basically everything, right? Ansible can provision stuff in the cloud using APIs, and for these APIs we had a big Ansible role that prepared all the hosts that we need for a training environment, and then we had additional roles that customized this general infrastructure, this general set of hosts down to something that's specific to the actual training. So we had a role that creates hosts, firewall settings, and so on, groups them into different clusters. So every participant to a training of us has uh, has their own virtual environment, and in that environment, we actually then start a role that installs Ocarino, that installs, say, Foreman, that installs a environment for teaching Puppet, or that installs Kubernetes clusters, or that just prepares some basic stuff so that you can install Terraform or Docker on these hosts. Now, the big thing about this is all of these things have one thing in common, and that is we start by using the Ansible host role, which actually deploys hosts in the cloud and sets up the infrastructure. That's the starting point where we were at. And that's also the point that I thought that we could change and that we should change, because, well, Ansible is a tool that does configuration as code very well. It's procedural, so you say, well, Ansible, please take all of these hosts that you have, do X, then do Y, then do Z, and so on. And every step of those will have to be performed in all these hosts. That is some kind of concurrency. However, this concurrency is limited in the sense that it only works as long as these hosts um, that only works as long as these hosts are accessible individually. So how could we actually improve upon that? So the general idea is, when you write Ansible code, it will look something like this. You have individual steps where you actually do stuff, and in these individual steps, you say, well, take all the hosts that you have and do something with them. In that case, say you want to set up a Kubernetes cluster, then you can install some packages on all of these hosts. Then Ansible will install all the packages on all of these hosts. And as soon as all the hosts are done, you go to the next stage. And the next stage, or task as it's called in Ansible, will do the next thing. As I said, this very dearly depends upon the fact that all these hosts are accessible individually. Now, that kind of makes you responsible for dealing with the dependencies of these different tasks, because everything is running in a linear fashion. So you say first do A, then do B, then do C. So you yourself have to take care about what has to be done first, what has to be done next, what has to be done after that. This is great when you want to install things. It's not great when you want to set up something in the cloud. And the reason why it's not great when you want to set up something in the cloud is, well, in the cloud, you usually have things that are their dependencies are very entangled with one another. So um, the say you want to set up a firewall. For a firewall to be set up, you need to first have to set up all the hosts that have to appear in the firewall. You will have to set up the hosts that the firewall be applied to. However, there might be some other hosts that don't actually appear in any of the settings of the firewall. So those could be running in parallel, but if you want to use Ansible, you will have to wait for those settings to be done. So boiling everything down to a linear fashion doesn't just work very, very well when you want to actually do things in the cloud, when you want to provision infrastructure. So that was the initial place where we were. And then along came my colleague Lukas Paluch. He's also IT consultant, and he had this very nice idea. Well, let's do something else. Seems like this linear fashion isn't just very very fitting for provisioning infrastructure. So instead, we could use something else for the infrastructure, but do the config again with Ansible because that works so well. So we could actually just offload the work of provisioning infrastructure to some other tool, and the other tool that he suggested was Terraform, because Terraform does things very much differently. So the plan was, well, let's provision infrastructure with Terraform and configure it afterwards with Ansible. Well, why? What is it actually that makes Terraform so different? And the reason why Terraform is so much different is when you write Terraform, Terraform doesn't care about the order that you put things in. With Ansible, you write linear code. You say, well, do this thing first and the next thing after that. With Terraform, you say, well, I want that, and I want that, and I want that. And the focus is on the and. It's not an and then. I just say, I want that. So say I want to, in the simplest case, say I want to create a local file, and this local file has to contain some SSH key, which is something that you usually need to in order to provision something in the cloud, because later on, whatever you want to have in the cloud, you want to access. So the idea is, well, I just say I want a TLS key. I want to have an SSH key, which I will call root, but uh, the name doesn't matter too much. And I also want a file, and that file has to contain that key. So what I say is, let's say I want to have file, and in that file, I say it has some content, and that content is actually just the key parameter of this other resource that I defined here. And the cool thing about Terraform is actually it has implicit dependencies. The fact that I mention this TLS private key in this other resource over here lets Terraform know that actually this local file depends on this private key. So Terraform itself will decide, well, I have to create that private key first and then the local file. It will not try to actually do these two steps at the same time or out of order. So I don't have to take care about the order, which is great. And it works even better when I do large stuff in the cloud. So the benefits of Terraform are that it actually is functional. I just say I want this, and and there's no such thing as order. There's no such thing as context. Everything will be resolved once I call Terraform on the code that I wrote, and it's highly concurrent in that sense. And this highly concurrence, we will see that later on. It's absolutely wonderful. So we decided to use Terraform for infrastructure, Ansible for the configuration. Now, that means that we have to rebuild the way our code works. And whenever you rebuild how the code works, you will have to decide what are the actual goals of that transformation. And the two big goals that we wanted to have is first, the framework that we build should be modular. so that when later on we decide, hey, we want another training, we could just use what we have, switch out some components, and everything's working. Also, we want these modules to be actually maintainable independently, so that we don't have to so that we don't have to take care in that sense to push these changes to all of the different trainings, but rather just have one place where the framework lives, one place where, say, our infrastructure modules live. We update those, and all trainings will be updated automatically. The other thing is, well, we do have a lot of Ansible code. We have a big Ansible code base, and we want to reuse that, because why just throw it away? It's configuring everything works so well with Ansible. We just do it identically as before, but want to find a way that we can use Terraform to trigger that. And then once we had these goals, the next question was, okay, so how do we actually combine Terraform and Ansible? I said, first we want to deploy the infrastructure with Terraform. Then we want to do configurations with Ansible. Now the question is, how do you get both of these talking to one another? And the very simple answer is, well, Terraform is doing something completely different than Ansible, so we can't get them talking directly to one another. It's much easier to just use some well-defined interface from Terraform to Ansible. And this well-defined interface is given to us by Ansible itself, because Ansible has this wonderful thing that's called the inventory. So as I said a few minutes ago, whenever you run Ansible code, you will have to tell it which hosts to run it on. And this this set of hosts comprises an inventory. These inventories could be put into a YAML file, and this YAML file itself is enough for Ansible to know everything about the hosts that it needs to know. So the idea was, well, let's just deploy hosts with Terraform, write all necessary data in an inventory. This inventory we create with Terraform, because Terraform can create local files from templates, and then just put that inventory to Ansible. Ansible will take the inventory and do its thing. So that's the plan. And easy as that, it works. So the question is, how do we actually create this inventory? And there's different ways of actually doing that, and we tried a lot of them. The first thing that we tried was just using template files and then templating that inventory together. It didn't work that well, because Terraform itself is a functional language. It's strongly typed, and as a strongly typed language, it doesn't work that well with templates, because templates are strings by nature, and Terraform doesn't like that so much. Instead, what we ended up doing is we wrote an inventory module. So we wrote Ansible code we wrote Terraform code that's packaged in a module. So Terraform code packages are called modules, and these modules you can actually load inside existing Terraform code, which is a great thing, because then you can reuse them. And in this module, we put the complete machinery to actually build an inventory. And in the first stage, that means we have a module that we call inventory. And this module that we call inventory, every module has inputs and outputs and something it does in between. But what it does in between is abstracted away. That's the point of this encapsulation. So it has inputs, it has outputs, and these inputs should be just YAML files. It should be it should be possible to give this inventory a list of YAML files, so a list of other inventories, and it will output some kind of merged inventory of those. The reason why we decided to do that is, well, infrastructure very quickly grows. And as it grows, the resulting inventories for Ansible get more complex and more complex. And the easiest way to build them would be to say, well, let's just create an inventory for every host that we have, and then just throw them all together, have some automated process which merges them. That's what this module does. And then just create a single file that contains a merged version of all of these inventories. That's the idea. So this inventory can actually import YAML files, and it can export one YAML file that contains the merged result. That's the big idea, and that worked very well. So yeah, we create several of these modules. Every of these modules can export their own inventory. Then we can use again a new instance of these modules to import the existing ones, merge them to a new inventory, and then we have an inventory that contains all the hosts that we need. This thing we write into a local file, put it to Ansible. Ansible will do its thing. So how does that work? Well, maybe later on I will have time to show you the actual code behind that. But from the user perspective, it's actually very simple. From the user perspective, you have this inventory module. We have it in our Git. And we specify a version of that module, which is again a nice feature of Terraform that you can specify versions of everything. And then you say, well, in the initial stage, we don't have any existing inventory, so we write an inventory in clear text. We write an inventory from as a string. You say in this here doc syntax, we say, well, we have hosts. We put an Ansible host in there. We put an Ansible user in there. We put a path to an Ansible private key in there. We could use the template language of Terraform. So we can use all the features of Terraform to actually create one single inventory for one single host. That's for one host. And then when we want to cluster these hosts, well, the easy thing is if we want to cluster hosts, we already have these hosts created by Terraform because that's the logic behind Terraform, bundling everything up into modules. So we already created those hosts. With those hosts, we created an Ansible inventory. And now all we have to do is merge these inventories. So we take, say, a Bastion host, the inventory, we take all members of a cluster, take their inventory, put them into a list. So that's what this concat does. And then say import that from YAML. And the module itself will do its magic. It will merge them, produce an inventory that contains all of those hosts. And as soon as we have all of those hosts in one inventory, we can then trigger an Ansible run. And that is great. That works very, very well. It's very modular because then you have one module for a single host. You can build a module for multiple hosts inside a cluster. You can build again a module for a training environment. This training environment will have several clusters, one for each participant. Each of those clusters will contain several individual hosts, and each of these individual hosts will have one inventory. Everything's merged in the end, and then you can trigger Ansible. With that, it's very easy to maintain because everything has the possibility to specify versions, so you don't make any breaking changes. You can outsource the maintenance of this inventory to one person, and this person will not have to copy the existing code to every other project. Just have to keep this inventory module up to date, and then others can decide whether they want to use the new version or whether they don't. And what's very important to me in there is also you produce very little boilerplate because like this is all that you need for a cluster of arbitrary size to create an inventory. It's like almost nothing. So everything's fine. Everything's well. What else could we do? We could stop here, and we did for a while, and then we decided, well, maybe we can do even better. And the way we did even better was by saying, well, we already have this inventory module. Why not extend it? And by extending, I mean put extra functionality into this module because now this module is loaded in every training environment. It's already loaded. So any feature that we put into this Ansible inventory module, it will be available to all people who provision a training environment. And of course, this is not limited to training environments. I could just go ahead and deploy a host from our Git. I could just deploy a Kubernetes cluster for some testing from our Git repository. Just say, I want this, do it now, wait 10 minutes, and it's there, and then I can work with it. So what else could we do regarding extra functionality? Well, let's say, okay, one thing that we could do is when we already create the inventory in Terraform, we could also start the Ansible run with Terraform. So what we did before was say we let Terraform do its thing. At the end, we create one inventory, and this inventory is passed on to an extra job that is Ansible, and Ansible will do its thing. We could use this Ansible inventory module to actually pull in the pull in Ansible into Terraform. And that's what we decided to try. So instead of just creating an inventory, we also create an extra resource that's called null resource in Terraform. Null resources are resources that don't exist, that just abstract away running a script, basically. So what we do is we say, well, Terraform, just run a script for us. And the cool thing is Terraform will take this block in here, because in Terraform everything is a block. These blocks are as you might remember, they contain these implicit dependencies. So Terraform will actually figure out when it's possible to run this block, and as soon as it's possible, not just when Terraform is done with everything that it's doing, as soon as possible, it will try to run whatever is defined in that block. And in that block, I can say, well, I want to have these triggers, so it will try to run the code as soon as possible. However, when I rerun Terraform, it will only rerun this code in there whenever one of these triggers does something. And then I can say, well, do something for me. And what you should do for me is, first of all, install all Ansible dependencies, Ansible Galaxy install, and then some requirements. And also run a playbook for me. And this playbook should actually be run with the generated inventory. I'm writing a local file inventory file name. So I'm generating an inventory, and as soon as it's possible, I'll run Ansible against this inventory. And that's a nice thing, because that actually allows me to trigger Ansible from Terraform, and that allows me to circumvent this problem of Ansible not being concurrent enough for all purposes. Because now every Terraform resource on its own can actually start an Ansible playbook run. So I do one Terraform, one Terraform apply, which is like Terraform do it. Terraform will provision hosts, and as soon as hosts in one group are done, it will already start Ansible for that group. As soon as the next group is done, it will start Ansible for that group. And these Ansible runs are completely separated from one another, so they don't have this blocking behavior of waiting for one step or one task to be done. So what we did is we restructured our GitLab. So we restructured our GitLab CI, our pipeline, from initially 2 stages. First stage, build hosts, build a network, build an inventory, and then pass that inventory to Ansible, run a playbook. That playbook contains some roles. It maybe depends on some collections. And what you could do instead is just do everything in Terraform. Do everything in Terraform does not mean that there's no Ansible anymore. No, it's still there. The difference is that now Terraform is actually telling Ansible when to run. So we just have one stage. This one stage is completely has completely automated dependency management, and in that automated dependency management, it will provision host the network, start the Ansible module, and that Ansible module will then create an inventory, run a playbook, and install whatever we need. Okay, so how would some of these modules then look? Well, there's 2 pieces to every of these Terraform modules in the end. First, of course, you have like the pure Terraform part. You have say you want to create a Kubernetes cluster, you have a Terraform file that creates hosts, you have a Terraform file that takes care of SSH. You have a Terraform file that takes care of a firewall. You have a Terraform file that takes care of load balancing, and you have a Terraform file that maybe takes care of making the Kubernetes credentials available. Then you have even more Terraform code, and this more Terraform code consists of an Ansible Terraform file, which contains the implementation of or the call of the Ansible inventory module. And this Ansible inventory module itself will then call a playbook. It will install requirements. It will install a role, or it will contain a role which is called Kubernetes node. And the important thing is there that you can actually include this role inside this Terraform module, so that you have just one unit of code, one module. This module ships with all its dependencies. Then as soon as you have that module, you can run anywhere. Okay, to summarize, the big idea that of how you can actually both simplify and speed up provisioning stuff in the cloud and configuring it is by using Terraform to do the infrastructure part, and then running Ansible, and use a specific Terraform module that actually builds the interface between both of them. So as Terraform starts everything, Terraform should be the thing where the actual interface is sitting. Now, as soon as you have that, you can think about inheriting inventories. So every Terraform module can create its own inventory, and as you already have a Terraform module that is responsible for inventory, you could build it in such a way that it actually merges existing inventories so that you don't have to rewrite them every time. And as a result, you can bundle all Ansible code with your Terraform code to build modules that contain everything that you need in order to run something. And this is something that I would like to show you, because of course I've prepared some live demo. The live demo that I've prepared first starts off with a single host. So let's see. Here is this is like our GitLab instance, and in this GitLab instance, I do have our a module that provisions a single host. This single host will be provisioned in Hetzner Cloud. The idea is, well, we want to have DNS, we want to have a host, we want to have a firewall, and we want to have this highly configurable. So if I look at variables, which is the inputs to our module, there's very, very many variables. Like it's highly configurable. And the reason why it's highly configurable is, well, there's so much that you can do with a single module. Single module will, of course, everything has names. Then SSH keys, inventories, and so on will have to be written to some place. That's why we can specify a files directory. Then you can specify which kind of host you want, where you want it, what kind of a image you want on that. That's all typical Terraform stuff. I don't want to bore you with that. The interesting thing is now that, of course, this module combines several things. It combines the host itself with some networking, with the possibility to create SSH keys for it, with the possibility to add existing SSH keys, which is a very important feature if you actually want to build clusters later on. DNS, of course, which DNS zone you want. We have a default which says atixtraining.de. Then how would you like your firewall to be created? Would you like your firewall to have a different name in the cloud? Maybe because you want to structure things differently. And then all allow rules, you can put them there. All deny rules, you can put them there. And then there's even some extra configuration for Ansible, where you say, do we want an inventory written to a file? Do we want Ansible groups to be auto-generated from labels that are put to the host, which is a very, very useful feature? Do we want to put extra variables for a single host? Also that's very important, because we want to auto-create that inventory later on. Which IP address should you use for the host? Should it be the public, the private IP, or whatever? Any requirements, any specific playbook you want to run for this host. So this module itself is highly configurable. Now let's see what it actually looks like when you just want to start that module. We have a group in our a GitLab group in our report in our in the Terraform project, which is called self-service. We can actually deploy hosts yourself. And now in there, the code is there's much less code, and that's a very good thing. So there's a little bit of boilerplate, which actually configures the providers. So if I open that up, you can see that we require the Hetzner cloud, we require AWS for DNS, we require some local stuff to happen. Then we set our passwords. So everything of this boilerplate stuff is in one file so that you can just copy it from one project to the next. Then there's variables which you could set for the project. I'm not going too deep into that. Let's look at the main TF because that's where actually something happens. And it's main TF. There's not so much. Just calls this host module. It's this hcloud host. I specify a version. I say where I want keys and whatnot to be put. I specify a host name. I specify a specific playbook to run, which is in this root directory. Path.module is where we are now. There should be a playbook.yaml file. And I don't want to create a firewall because that's not necessary for this kind of a project. And now let's go to my personal branch because this like we have several branches and each of these branches is tied to a unique instance of the provisioned infrastructure. And in there, I can just say, well, let's create that. So let's go to pipelines, run a pipeline. I'm running the pipeline for my own version of the repository, and this pipeline is now running. And what it's doing is, first of all, it's linting the code. So it's checking, does this code match our code standards? It's this usual thing. As soon as that is done, it will create a plan with Terraform. This plan will actually display before we start provisioning anything in the cloud. It will display what it's planning to create, because that is very important to. So this is an advice that I can give you. If you want to use Terraform in a pipeline, keep this plan and apply step separate, because you generally want to first see what the pipeline will do before you actually do it, because this pipeline could destroy infrastructure. So usually what you do is do a plan step first, and before actually applying it, have someone review the actual changes that are in that plan, and we can have a look. It's taking a few seconds, hopefully, and then it will tell us what it will want to create. Here we go. So what this module will create for us, a lot of stuff. So it will create an A record for us. It will create an CNAME record for us, so that's DNS. It will create a server. It will create SSH keys, a file which contains the SSH key because we want to access that host later on. It will also create another another key called root. It will create a TLS private key, and then it will upload it to the cloud, sorry. And in the final step, it will create an Ansible inventory from that. This is what the Ansible inventory will look like. It knows that ahead of time. And after all, it will run a playbook. And this playbook will do something with that inventory. And we will see what it does. So I'm happy with that. This looks like I want to proceed. So let's just run the apply step. And in the apply step, we can see what it's doing. First of all, it will load everything. Again, this will take a few seconds. And then as the plan is already done, it will start issuing API requests to Hetzner Cloud and AWS. In the meantime, I can show you something that's a little bit more involved, which we will have a look soon after that. And what's a little bit more involved is our Kubernetes cluster module, because we also have a Kubernetes cluster module. It looks very, very much alike to this minimal hcloud, except that there's not just one host that's created, but several. So now in this Kubernetes cluster module, we have a host's Terraform file, and this host Terraform file will create several control plane nodes. So it has a count, and it loads this existing hcloud host module again. The same thing for the workers. Also, you can issue a count there. It will do exactly the same thing, set up everything as we need, set up a firewall as we need that. And it also includes, and that's the cool thing, it also includes a role which is called Kubernetes node. And that's versioned in another repository, but it's an Ansible role which installs Kubernetes on one server. And the cool thing is here that this module bundles a playbook, and this playbook installs containerd. It installs this Kubernetes node on a Bootstrap node. It installs even more Kubernetes nodes for the control plane, and then it adds worker nodes. So actually, this Kubernetes cluster module, you just load it exactly the same way that you would load a single host, but now you get an entire cluster instead of one host. All the effort of building Kubernetes is abstracted away in one place where one person can maintain it. Okay, let's have a look what the pipeline has been doing. So it's applying the cached plan that we created before. And here it's creating keys, it's creating stuff, Here's already a creation complete. And as you see, many of these things are running in parallel. And there's no order that you might actually see yourself. And the reason why you don't see this order yourself is because Terraform is taking care of that. Terraform is figuring out, hey, what's depending on what, and what needs what, and when can I start the next step for everything. Here you see we are, as soon as the server was created, we started creating an A record for that server. And as soon as that A record was created, we simultaneously started creating a CNAME for that A record and also already run the playbook. So even before DNS was complete, we were able to run Ansible for that host, because Terraform knew that it doesn't even need that CNAME record. It only needs this A record, and that A record is done at that point. And here are the Ansible logs. The Ansible playbook is very simple. It's just running a ping for this host to check connectivity, and that was successful. And as that was successful, we are done. And as a final step, it outputs the inventory so that we can check what we successfully created. And we are now do have a host. And I'd like to show you that we indeed have that host by downloading the keys. Here's the keys. Let me extract them. Artifacts. Here's an SSH key. Here's the inventory. From the inventory, I can just take the host name. That's it. Or terminal. SSH at. And probably I've been to that host before. No, I haven't. And I forgot to enter the private key. Sorry for that. ID RSA. And here we are. So now we're in the cloud. And the cool thing is we can leave the cloud almost instantly by just saying, well, destroy that, please. That's it. Okay, now it's destroying. Probably 1 minute, this host will be gone. I can close my terminal because I don't need it anymore. Okay, now we have 15 minutes left. And in this 15 minutes, I will I will try to simultaneously do one thing and answer your questions. And the one thing that I would like to show you, because that's something that I'm proud of, is I already showed you the Kubernetes module, and I would like to give you a demo of the Kubernetes module. Here's something very like to the HCloud host, or the single host repository that we had. There's a main TF, and this main TF, I'm just doing one call to a module. I invoke this Kubernetes cluster module and I say, well, I want these files to be in an artifact directory because that's captured by the pipeline. I'm giving this a name. This var.environment is actually the branch name. And I do have one control plane node and I have two worker nodes. Let me go to my own branch in there because then I don't mess up anything for anyone else. And then again, run the pipeline. Okay. So this is linting the code. And as it's linting the code and preparing a plan, let me have a look if there are any questions. Oh, no questions yet. So feel free to pose any questions at any time. If not, I will just keep on looking at the pipeline and let's see what the destruction job on that other host is doing. So the other host is gone already. Let me show you. Nothing's happening. So the DNS record is still cached somewhere, but we're not ending up at the host anymore because the host is gone. Let's see what's happening here. The lint job is already done. Let's check my code. Code is fine. The plan is already done as well. And let's look at the plan now because this is like a little bit more complicated. The generated inventory will look like will contain one control plane node, which is also the bootstrap node for the included role. It will contain a group that has all nodes in the cluster. For these, some variables are set globally. And of course, there's a group that contains all workers because these need different configuration than the others. Now that's the generated inventory. Looking at what happens to the hosts themselves is a little bit more impressive, I think, because now there's already almost 20 resources that are created in the cloud, and one of these resources contains a firewall that has wildcard entries for all the existing hosts. Here we have we enable TCP traffic internally and UDP traffic internally for all hosts. That's the reason why these source IPs will only be known after apply, because now we're just in the plan stage. We don't know yet what these IP addresses are. So let's start the pipeline. And it's really as easy as that. As soon as you've got your Terraform and Ansible code working together, you just have to wait for the pipeline to do its thing. And now this pipeline will do exactly what the previous pipeline did, but instead it will create several hosts and run a playbook on those hosts that installs Kubernetes. Let's have a look. In the meantime, I see there still are no questions. So if you would like to pose any questions, feel free. Okay, we started creating. So what this is doing now, it's already creating some DNS records in the cloud. It's already creating hosts. Here we have the servers for the workers. We're having the server for the control plane. That's already done. DNS is almost done. This is usually what takes most of the time, because DNS records are not the fastest thing. And now it should only take a few seconds before the playbook starts running. Okay, now we're starting the playbook. So first step in the playbook, before running the playbook, actually is installing all dependencies that we need, because to start a installation, for Kubernetes, we first need containerd, and there's a role that we just loaded from the Ansible Galaxy that's created by Geerling guy, the famous Geerling guy. And then we run a playbook that actually installs Kubernetes. And here we're seeing still containerd running. Oh, I see a question. Great. Yes, absolutely. So the question is, could you please plan a session for CI/CD? Of course, we can do that. Sure. I will talk to Inga at marketing. She will find she will find a date where we can actually do a session on how to do CI/CD. Any specific any specific direction that you are interested in for CI/CD? And in the meantime, it finished installing containerd, and now we're installing kubeadm, kubelet, and kubectl. This is already done. We're bootstrapping a control plane at the moment. Bootstrap the control plane with kubeadm in it, and this might actually take a few seconds. As soon as that is done, nodes will be the control plane node will be ready, and after that, we can install Kubernetes on the worker nodes. And after that, hopefully the pipeline will present us with some artifacts so that we can access Kubernetes. Okay, so now the workers are doing their thing. We just enabled NetBridge, enabled IP tables, or let Kubernetes manage IP tables, installing kubeadm, kubelet, and kubectl. And by the way, one of the reasons why this is so great is you can load this module several times, because if I wanted to load this module multiple times, all I would have needed to do is put an extra block of Kubernetes in here, and then I would have 2 Kubernetes clusters. And the complete installation of Kubernetes in these clusters would be entirely parallel, because Terraform itself will manage the Ansible playbook run, and it will see that there's no cross references between these clusters, and then it will start completely independent Ansible runs, which is absolutely amazing. Oh, that's it. We're done. That's it. Last thing that it did was fetch the kubeconfig from the now provisioned cluster. That worked. I'm pretty sure that it should be now in our job artifacts. Let's see. So these are the old artifacts. Let me delete them. These are the new ones. Artifacts. There's the roles directory, because these roles were downloaded in this should here's the container D. There's an admin.conf, and this is a kubeconfig. So let me see if that kubeconfig is working. Port kubeconfig equals current working directory admin.conf tail get nodes. And here we have a working Kubernetes cluster. We could now deploy stuff to that cluster. We could even, as this is a pipeline artifact, put an extra stage in the pipeline that installs whatever in that cluster we want, and then we could entirely manage this Kubernetes just by rerunning that pipeline in the GitOps fashion. We could also say, well, as a last step after provisioning that cluster, add it to some Kubernetes management plane, such as Rancher or Argo CD or something else, so that we don't even need to keep that kubeconfig. We could just throw it away after deploying the cluster. You shouldn't do that, but we could do that. Or we shouldn't. We could also just put it in a backup storage, never touch it unless we have to do some disaster recovery, and run and manage Kubernetes entirely from GitLab, which we've already did in a few projects, and it works like a charm. Great thing. Okay, with that, I'll summarize again. So big idea is when you want to use Terraform and Ansible, you will need to think about how to interface between both of them. And my personal recommendation is start Terraform first, and from Terraform create, build a module that creates an inventory. And use this inventory to call Ansible, because this is like the easiest way to get things done, and it scales absolutely perfectly. It's wonderful. If you already have that, consider building this module in a way such that it can inherit from other inventories, so that you don't have to rebuild these inventories every time that you do something. With our modules, it's every host creates an inventory. So every host has its inventory with it. So that if I want to bundle multiple hosts, I just need to inherit all the inventories that these hosts built originally. Every other module itself also includes an inventory with all hosts in there. So if I want multiple Kubernetes clusters, I don't have to dig through all the created hosts. I just have to say, well, this Kubernetes cluster already has an inventory. If I have two of these clusters, just merge them together, put that to Ansible. Ansible can deal with both of these clusters now. And when you build these modules, include all necessary roles. One of the other great things here is I actually don't need automation, or I don't need CI/CD to deploy these hosts. I could just download this Kubernetes module, this Kubernetes cluster module. I could just download it. It's here in the infrastructure registry. I could just download it and then run it from my local machine without having any access to the bundle to the roles in our GitLab, because the roles that are necessary for running this module are bundled with the module. And with that, I think I've explained enough about the summary. There's one more question. Is it some online Kubernetes playground website? No, in that case, not. This is a very good question, and I've also thought about implementing something like that. In this case, this Kubernetes playground, it's just called Kubernetes playground because I use this repository every time that I want to try something in Kubernetes. So every time that I want to try something in Kubernetes, instead of setting up a cluster myself and going through all of the effort, or maintaining a cluster as a backup thing so that I can, or maintaining a development cluster 24/7. Instead, I just go to this repository, deploy that cluster. It takes like 5 minutes and 30 seconds. Then do what I want in there, and then just tear it down, and everything's fine. I hope that answers the question. Also, that's something that I would recommend doing, because if you are already in the cloud, take advantage of the cloud and be quick. Like, deploy stuff for 10 minutes, that's fine, because you only pay for 10 minutes. Right. Thank you for the question. And I think we're on time. Great. If you have any other questions, please don't hesitate to shoot me an email. My email address is, I hope you can see that here. It's fries@artix.de. Fries@artix. That's my email address. If you have any further questions, please don't hesitate. Um, Very good question. The question is, can you please post the link for the Terraform inventory module? Unfortunately, I can't, because the Terraform inventory module is something that I built, and it's in our GitLab on its own. So and that of course is like in our virtual private network. However, if you are interested in any details of how to actually build such a module, I'm happy to answer. So please don't hesitate in shooting me an email. I'm very happy to answer any questions about that. Oh, and the last thing, thank you very much for the great and very interesting presentation. Thank you very much. It was a pleasure. I'm very happy that many people actually also stayed till the very end. It was a very great pleasure, and I hope that I can meet you again when we do our CI/CD session. With that, I wish you a very nice afternoon, and see you next time. Bye.